So again, if there are 10 students, then everybody needs to be assigned a 2-digit number. Okay? 10 students, everybody gets assigned a 2-digit number. So we have 01, 02, 03.
I always say 01 and 08.
And all the way up to 10. Oh, I'm sorry. We only are going to pull 10 numbers, a sample of 10 from a population of 78. But that doesn't change the 2-digit number. So 01, 02, 03, all the way up to actually 77, 78. Those are all the numbers that we're going to pick from. We have to pick the first 10 that we come across. So is person number 27 in our list? Yes, if we've got 78 people, we will have a person number 27. How about person number 81? No, we don't get up to 81. Do we have a person number 67? Yes. 84? No. 16 is a yes. 01 is a yes. 82 is a no. Do we follow how we're doing that? And we're going to go until we get 10 people, but I'm going to move past that. Okay, and in exercise 5, suppose that you want to randomly select 60. So we're going to take a sample. That's our sample of 60. There are 625 employees, though. So now every employee needs a 3-digit number. We have 001, 002, all the way up to 625. And those will be the identification numbers for 625 employees. And then, if we had a string of numbers, like if we went up here and we started with this one, we would look at a string of 3, 680. Our list doesn't go up to 680. 005 would be person number 5, so that's good. 364 would be person number 364, that's good. And depending on how many people are in your population, that dictates how many digits are in their identification number. Okay? And then we would choose 60. So when they say explain, you would say, number 1, all 625 employees get assigned a 3-digit number starting with 001 up till 625. And then you go through your string of numbers and you're looking for 3-digit increments where we cover the 620, we pull any number that's below 625. Okay? I don't know. It's an easy concept, random number tables. I don't honestly think it would be on your Regents, but if it ever was and you've never seen it, you would have no clue what the heck this thing is. So that might be really all we see on it as far as coming up in the notes. All right? Now, were there any questions on your homework? There was one number table question, and that was 6B. So I will re-look at that. Let me read this quickly about these volunteers. There are 50 volunteers, so everyone gets assigned how many digits? How many digits? 2. So we have person 01, 02, all the way up to 50. And then we would just start at any random, we can pick which row we start on row 10 of a random number table, and look for every 2 digits and keep pulling anything that's under 50. Okay? And we might take our first 25, and those 25 are in control group A. Let's say those would be the 25 who use the app for a week, and then the remaining 25 that don't get picked initially will be the 25 who do not use the app for a week. and you have randomly assigned 25 to one group and 25 to another. Okay? There are other ways to do randomizations, like I said. Computer software is going to be your best bet. But this is how you would do it manually. Another way you could do it manually, you could put 50 names in a hat and just pull out 25. That seems a little more obvious, doesn't it? But they do it very mathematically, and they set up these random number tables. Okay? Any questions on the homework? Cool. Number 8. If you were trying to conduct a survey of political preferences for likely voters in an upcoming election and decided to dial 1,000 randomly generated landline phone numbers, why might this still introduce bias into the sampling? So think about this day and age. If you just called 1,000 landline phone numbers, who would you be excluding? People who don't have a landline. I wouldn't ever have any chance of getting picked for that because I don't have a landline, right? And many of you probably don't have landlines. So the thing with being fair and avoiding this bias is a good key vocab word. I need to make sure everybody in the population is equally likely to be picked. So I would need to, probably the only thing is going through Social Security numbers. Everybody has a Social Security number, okay? So, and that would be their identification number. So I can't say, oh, I'm just going to call these phone numbers because I've excluded a whole bunch of the population. They have no chance of being picked. And then you don't know, is there something about people that have landlines? People that have landlines are probably older, right? And so now you if they all answer your survey in a certain way, now you're wondering, is that really a good representation of the entire population? No, that's a good representation of maybe older people, because they're the only ones you've really asked. Not necessarily, but that seems to be what happens with landlines. Like my parents have one. Not that they're old. Do you have one?
I don't have a smartphone.
Oh, yeah, so you like...
I'm old.
Yeah, really old. So you got to think about that stuff when you're picking a survey and picking who to question in a survey. Anything else? Okay. Pass that forward, please. And you're going to need your calculators, I think. You can... I don't think it'll be the end of the world if you don't, but... I know you guys know what the average is, correct? You know mean, median, mode, and is that it? Mean, median, mode, and range? Those are kind of your basic ones. And still those are obviously important things to look at about data, but there's this new concept of standard deviation. And that I don't think you've ever heard of. Has anybody heard of standard deviation? You have, but most people probably not, right? Okay? So I decided to teach standard deviation starting with an example. So I've put 2 football players' names here, and this is each player's average points per game in fantasy football. So whether or not, or you could just, if you don't know about fantasy football, you could just say it's their average number of points per game in an actual game. So which player looks better to you based on their per game average? Marvin Harrison or Terrell Owens? Who looks better? Marvin Harrison, really, because his per game average is slightly higher, but not by a ton. So you might say that Marvin Harrison is slightly better, okay? But then we have this standard deviation, and I apologize, it's been cut off a little bit, but Marvin Harrison's is 6.5. and Terrell Owens is 2.25. Okay? Standard deviation is a measure of consistency. Okay? Measure of consistency. I'm going to write that first. And the smaller your standard deviation, the more consistent you are. So that would be Terrell Owens in this case. His is much smaller. So the smaller your standard deviation, the more consistency. And the more consistency really means less variability, which means Terrell Owens scores around 14.86 points per game, give or take 2.25. So he met, and it doesn't have to be just limited to that, but more often than not, he scores within 2.25 points of 14.86. So he might score 2.25 points more than that, or 2.25 points less than that, but he's pretty centered around 14.86. Okay? So if I go down here and I let this be Terrell Owens, we'll say, okay? Right at the base of the peak is kind of their average. So his average would be 14.86. But if I add 14.86 and add his standard deviation to that, that brings us to 17.11. So more often than not, he can score up to 17.11 or 2.25 below 14.86, which is 12.61. Okay, so that's Terrell Owens. More often than not, he's going to score somewhere between 12.61 and 17.11 points. Whereas Marvin Harrison, having a standard deviation of 6.5, means more times than not, he's going to score 6.5 points above that or 6.5 points below that. So 14.89 is his average. So that would go right in the middle of his curve. But he could score 6.5 points above that, which would be 21.39. I'll just put that over here because it's a little further away. Or he could score 6.5 points below that, so 14.89 minus 6.5 points would be as low as 8.39. So when you look at those two side by side, Terrell Owens is much more predictable, much more consistent. His points scored are more closely knit to the average, versus Marvin Harrison is kind of a wild card. He could have a stellar game and do really, really well, or he could be terrible and have a pretty poor game and only score 8 points. So you don't know. If both of these people are on your team and you have a pretty comfortable lead and you just want to play it safe, you're going to play Terrell Owens because you know exactly what you're going to get from him, somewhere between 12 and 17. But if you maybe are losing by a lot and you need a prayer and you say, okay, well, I need my wide receiver. I need him to score 20 points. Well, Terrell Owens probably is not going to score 20 points. Marvin Harrison does vary a lot, so his variability is much larger, so he might score 20 points. I mean, technically, either of them could score 20 points. It's not that Terrell Owens can't, it's that usually he does not. And Marvin Harrison has much more variability, so you have a better chance of playing him. Okay? But if you have a comfortable lead and you just want to play it safe, you'd want to play Terrell Owens, because if you play Marvin Harrison and God forbid he has a terrible game, that could lose the game for you. Right? So knowing how consistent your players are, you want to play it safe when you got a comfortable lead sort of thing, or if you know you need a prayer, you might want to be more risky. And granted, if you need a prayer anyway and Marvin Harrison has 8 points, who cares? You probably weren't going to get it with Terrell Owens either. But you might get a 21-point game from Marvin Harrison and get that prayer answered, right? Does that make sense a little bit? That's just the general scope of what standard deviation is. So up here I have standard deviation gives a measure of consistency or lack thereof. It could be variability. Okay, the higher your standard deviation, that means the higher your variability. And we're going to get a chart in a couple of days about, was it tomorrow maybe? Yeah, tomorrow. Giving us the exact percentages. But one standard deviation away, so in Terrell Owens' case, from 12.61 to 17.11, this means that 68% of the time, Terrell Owens scores between this and that. And 68% means a majority, right? So 68% is the exact percentage, and those percentages aren't going to change. You score within one standard deviation of your average. So that could be one standard deviation above or one standard deviation below. But that happens 68% of the time. 2 standard deviations away is 95% of the time. Okay? So if I take Terrell Owens, for example, I just did one standard deviation away. I took that 14.86 and I added his 2.25 one time to get 17.11. But if I wanted to go a second standard deviation away, I would add 2.25 again, and I would get 19.36. So that's his second standard deviation away on the upper side of things. And on the lower side of things, I would do 14.86 as his average, and I would subtract his standard deviation 2 times. So that would put me down at 10.36. So let me be clear again. If you needed someone to score 20 points to help you win a game, because you were down by that much, Terrell Owens almost never scores above 19.36. 95% of the time he's between these two numbers, which means there's only a 5% chance or less that he's actually going to score the 20 points that you need. Okay? Versus Marvin Harrison, here's one standard deviation away. So 68% of the time, he might score that 20 points that you need. Okay? If you doubled this standard deviation for Marvin Harrison and went 2 standard deviations away, we would take our 14.89 and we would add our 6.5 twice to get 2 standard deviations away, so 27.89. And 2 standard deviations away on the bottom side, if I subtract 6.5 twice, would bring me to 1.89. So 95% of the time for Marvin Harrison, he scores between 1.89 and 27.89 points. Well, that's quite the range, isn't it? He's not very consistent with that high standard deviation. Okay? So the blanks that we have here is that Marvin Harrison scores within 6.5 of his average, 14.89, and that's 68% of the time. The second part of that sentence is going to get at the 2 standard deviations. So if 1 standard deviation is 6.5, then 2 standard deviations means that he has to score within 13 points of his average of 14.89, and that happens 95% of the time. With Terrell Owens, his standard deviation, 1 standard deviation was 2.25 of his average, which is 14.86. So he scores within 2.25 points of 14.86. 68% of the time, and then 2 standard deviations would be 2 times 2.25, which is 4.5 of his average, 14.86. So he, 95% of the time, he stays within 4.5 points of his average. Whereas Marvin Harrison stays only within 13 points of his average. Again, higher variability for Marvin Harrison. Okay? Calculator work here. It says to use our calculator to determine the mean, median, and quartiles for the data set. So, if you have your calculator, hit your stat button and edit. Okay? A lot of times in this chapter we're going to have to insert data. So we edit, and if there's anything there, scroll up, highlight the list, hit clear. It's going to clear out everything that was down here, so that when you scroll back down, it's going to empty the list. And then we need to insert those numbers. So 56, enter. 68, enter. Enter all those. If you're having any trouble clearing stuff, bring your calculator up to me right now. Or if you don't know where we are, bring it up to me right now.
I don't know which one.
Stat.
Mm-hmm.
Right there.
Mm-hmm.
Edit. Enter. Hmm? Stat.
Oh.
Edit. And you've got nothing there, so just enter. Okay? Now, how many people were in Mr. Weiler's class? Just enter the data.
That data goes in.
18, right? So if you scroll up to your last number that you plugged in, you can double check that you didn't miss anything, because that person is your 18th person, and it'll tell you that at the bottom. Okay? So sometimes when you're entering lists, you want to double check that, make sure you don't forget anything, because it'll throw off all your numbers. So we have all those in there. Now, we're looking for the mean, median, and mode. So once you have all the data in there, and keep in mind we put it in list 1, L1, under your stat key again, hit stat, and then calculate. So you'd go over to calc, and we're just doing one variable, statistics. That's all we'll use on this menu when we have a list entered in. And when you hit that, it'll ask you what list you're working with, and that's list 1. We don't have multiple frequencies, so it's not like any score from our list happened 10 times and we want the calculator to do all that. So just scroll down to calculate and hit enter. Okay? Now here's some of those symbols, the most important ones. X bar, that's our sample average. Okay? We took all 18 students, so it's technically the entire population of his class, but that's our average. X bar equals 83.7. I'm going to write that down there. X bar equals 83.7. Okay, couple other things here. These two, the SX and the OX, it's not an O, but it's a Greek letter, but we're just going to call it an O for now. Those are two different standard deviations, okay? The calculator is assuming that we've only typed in a sample, okay? And so we almost always, unless it says differently, this is the sample standard deviation. So S with a subscript of X, and in this case that's 12.0. That means your sample standard deviation. So that is the actual standard deviation of the numbers I just plugged in. So if your average is 83.7, then 68% of the time, students score within 12 points of that. That's what that tells us. 68% of the time, students score within 12 points of 83.7, which is the average in this case. What does that percentage grow to when we talk about two standard deviations? Thank you. What was that second percentage? If you go two standard deviations away, look up top. 95. So I'm going to write another sentence. I'm actually only going to change the numbers. 95% of the time, keep all this same, students score within, if one standard deviation is 12 points, two standard deviations is 24.
Points of what?
24 points of 83.7, because 83.7 is the average here. So that's the standard deviation of the numbers that we actually plugged in. And so that is 12. What this other symbol is that we see on our calculator, that's the population standard deviation, and that's 11.7. I'm going to use SD for standard deviation. So that's like so the calculator does it two ways. The second way, they're assuming you've only typed in 18 random people's results out of like a whole population of 1 million. And so they kind of adjust for the fact that there's a little bit of error involved if you've only taken 18 out of the entire population. Okay? So it should say and I'll talk about it as we come across it, which standard deviation to use and why. Just know your symbols for now. That's the sample standard deviation, and that's the population. Okay? As far as your quartiles and the rest of the, like a box and whisker plot would go, that's, remember your 5-number summaries? Your minimum, your maximum.
How do I get to that?
I just scrolled down. I'm still on the same page. I just went down, down, down. So your minimum, your maximum, your Q1, your median, and your Q3. Okay? So if I set up my box and whisker plot, a number line, I'm going to go from 50 to 100, 60, 70, 80, 90. And those are my key 5 numbers. The minimum of 56 would go right about there. The first quartile of 75 would go about there. The median of 84.5 would go about here. Median meaning middle. Q3 is 93. And your max is 100. And your whiskers come in from the sides. Your box is in the middle. And that's your box and whisker plot. This is Algebra 1 stuff, really. then part B asks for the interquartile range. That's your inner 50%. So your interquartile range is from 75 to 93. Okay? In theory, that should mean that 50% falls between 75 and 93. Because when you've split things up into quarters, you've got 25% here, 25% there, 25% there, and 25% there. Okay, any questions on that? All right, we are going to, this is going to knock your socks off. We're going to not have homework tonight. I take that back. I can't do that. You have to have homework. I'm going to put up 3 questions on my website. 3 spiral questions.
Why?
And that's going to be your homework.
Why?
Because I can't have you do nothing. But I don't want to hand you a paper and you'll know how to do some of it. So we'll finish these notes tomorrow. And your homework tonight is just going to be 3 questions. And they will be spiral type questions.
This will help us with the optional quiz.
Remember that your optional test is tomorrow after school. It'll take about a half an hour. Okay? And hold on. If you want a review sheet, the spiral that we did over the weekend is a good review sheet, and I will also write tonight's 3 questions so that they're reviewing for tomorrow's optional assessment as well.
I think you're doing right this time.
What's that?
I think you did spiral there.
I did. He asked me to come to this class, and I hadn't checked the board. Okay, perfect. Yeah, or Thursday, you can do it.